Hello everyone. Today we're talking about proportional parts within triangles. We've already seen a little bit of this when we were talking about our similar triangles, our similar polygons. But essentially now we're going to go into how parallel sides within triangles and parallel sides and midpoints within triangles affect similarity. So first things first, proportional parts within triangles. In any triangle, a line parallel to one side of the triangle separates the two sides proportionally. This is known as the triangle proportionality theorem. The converse of this is also true. Now we've seen examples like this in the assignments from earlier in the week, but essentially, if xy is parallel to rs, then the ratio between rx and xt is equal to the ratio between sy and yt. Or, if rx to xt has the same ratio of sy to yt, then xy must be parallel to rs. We're going to use this to establish proportionality within the triangles. So example 1. In triangle ABC, EF is parallel to CB. Find x. So since EF is parallel to CB, we can set up the proportion statement of AF to FB must be equal to AE to EC. Fill in what we know. Our AF, x plus 22, to x plus 2 must be equal to 18 to 6. Run our cross product. We end up with 6x plus 132 is equal to 18x plus 36. Combine our like terms. 96 is equal to 12x. Divide both sides by 12. 8 equals x. Example 2. In triangle GHJ, HK is 5, KG is 10, and JL is 1/2 the length of LG. And we want to know, is HK parallel to KL? So we can say that this is x and this is 2x. That would suffice that JL is 1/2 the length of LG because x is 1/2 of 2x. So we're going to set up our relationship based on the proportionality theorem. So if HK to KG is 5, 10, we need to establish that these two are going to be equal to JL to LG. Well, JL to LG is x to 2x, which simplifies down to 1/2. The 5 over 10 from that was HK to KL also simplifies down to 1/2. Because this is proportional to that, HK is parallel to KL by the triangle proportionality theorem. So just different ways to look at our triangle proportionality theorem. Let's box up the actual theorem line for you. All right. Mid-segments. If x and y are midpoints of R and T, of RT and ST, so x and y are midpoints, which means that Rx is equal to xt and Ty is equal to ys. The triangle mid-segment theorem states that a mid-segment is parallel to the third side and is half of its length. So, essentially, that if x is a midpoint and y is a midpoint, then the line xy is going to be parallel to rs. It's going to be half the measure of rs. So let's take a look at some applications of the mid-segments. Example 3, solve for x. It doesn't look like we have very much information, but we have some congruency marks that tell us this point is a midpoint and this point is a midpoint. Based on our mid-segment theorem, this line here must be parallel to that line there, and because it is based off of midpoints, this x is going to be half of 35. So our equation is essentially x is equal to 35 over 2. And we could leave it like that, or we could simplify it down to 17.5 or 17 and a half. And that's it. We established this is a midpoint, that's midpoint, and we can apply our mid-segment rule to say that this middle side, this middle proportional line, is half of whatever the third bottom side is. This can be true no matter what orientation of the triangle is present. Such as example 4. JH is the mid-segment of KLM, a triangle KLM. So JH is the mid-segment. Let's go ahead and mark that real quick because there are a few lines here. There's our mid-segment, which means that that is proportional to that. That is congruent to that. Find the value of x. Well, same sort of thing we did last time. We've established this is a mid-segment, so this x must be half of whatever this x plus 7 is. So we're going to write that as our equation. X is equal to x plus 7 over 2. Move things around, that becomes 2x is equal to x plus 7. Combine our like terms by subtracting x from both sides, and we end up with x is equal to 7. All right, last thing for today. Proportional parts with parallel lines. I know it looks like there's a lot in here, but it uses terms that we've talked about before. So when 3 or more parallel lines cut 2 transversals, they separate the transversals into proportional parts. If the ratio of the parts is 1, then the parallel lines separate the transversals into congruent parts. What does this mean? If we take a look at these images, if line 1, line 2, and line 3 are parallel, then the relationship between A to B, so the ratio of A to B, will be equal to the ratio of C to D. At the same time, if the lines are parallel and the ratio comes out to a 1, let's say it's a 1-to-1 relationship, then the other corresponding ratio will be a 1-to-1 relationship. So if U to V comes out to 1-to-1, then W to X will also be 1-to-1. So how does this look application-wise? Well, example 5, refer to lines 1, 2, and 3 above. If A equals 3, B equals 8, and C equals 5, find D. Well, lines 1, 2, and 3, so we're dealing with this figure here. A is 3, B is 8, C is 5, find D. So we've established that 1, 2, and 3 are parallel. Therefore, we can use our proportional here and say that A to B must be equal to C to D. Pulling what we know, 3 to 8 must be equal to 5 to D. Do our cross product. We end up with 3D equals 40. Divide both sides by 3. D is equal to 13 1/3. So even though finding a nice clean proportional fraction of 5 to something to equal 3/8 might be a daunting task for us via calculator or via previous math, we can use this rule, essentially, our proportional parts with parallel lines rule, to find proportional fractions given parallel lines. One last one. Example 6. Example 6. Let's see. Parallel line TE is parallel to OU. Find X. I know what you're thinking. We were just talking about 3 parallel lines, and there are only 2 parallel lines here present. But, as a general rule of thumb with triangles, we can draw a third parallel line that goes through R such that this line, and this line are all parallel to each other. Because through points exist lines, going back to our basically first class. Lines go through points, and we can have exactly one line going through this point that is parallel to the other lines. As such, we have our 3 parallel lines. We can then make our setup of OT to TR must be equal to EU to ER. Plug in what we know, OT is 6, TR is 15, EU is our unknown value, and ER is 10. Cross multiply. 60 equals 15x. Divide both sides by 15, and 4 is equal to x. All right. Folks, please ask questions if you have any questions. I'll put a little practice in the Schoology folder, and we'll keep talking about this tomorrow and Friday.